let's look at some rational expressions in G and H here to figure out if we have continuity or if it's discontinuous. So I have the limit as x is approaching -1 of x squared minus 4 over x plus 3. So if I'm approaching -1, the first thing I want to do is sub in -1 for my x. So I end up with -1 squared would be 1, 1 minus 4 would be -3 over 2, which again, that would be numerical. It's not a number over 0 or 0 divided by 0, so that means that it's continuous. Now you might be looking here, we have a denominator, right? Since it's a rational expression, x plus 3, so x here cannot equal -3, because -3 plus 3 would equal 0, but it's only talking about the limit as I'm approaching -1. So I'm not approaching -3, I'm approaching at -1, and so it is continuous at that x value of -1. What about the limit as x approaches -3 of x squared plus 4 over x plus 3, which I think you can probably guess what's going to happen here because, again, we just said x cannot equal -3. So let's sub it in. -3 squared plus 4 over -3 plus 3 is 9, 10, 11, 12, 13 over 0. So that 13 over 0 would be, if we wanted to go back, would be this number over 0. So this means that the function has infinite discontinuity and the limit does not exist. And we can also see here that the limit does not exist because, again, I'm approaching -3, I'm nearing -3, and -3 plus 3 is 0, which I can't have as the denominator. So I would say here that the limit does not exist and it's infinite discontinuity. Okay, let's continue on. With I and with, oh, I don't know where J went. I and K, I guess. What about the limit as x approaches 1 of x squared minus 1 over x minus 1? So these two are different from each other. So let's go ahead and sub in 1 in for x and see what happens. You can work ahead of me. One squared is 1, 1 minus 1 is 0, 1 minus 1 is 0. So I have 0 divided by 0, which, hold on, means it's indeterminate. Which means I haven't determined anything yet, right? It's indeterminate. So what I need to do is, like it's set up above, I need to rationalize, simplify, factor. And if I were to look at this example, x squared minus 1 looks like a difference of squares. So what I can do is, let's try factoring this. So therefore, the limit as x is approaching 1 from both sides, right, is take the x squared minus 1, and I have x minus 1, x plus 1. And the denominator of x minus 1 I can't do anything with, so I can just keep it, put brackets around it, x minus 1, and then I think you can see there, I can cancel out my x minus 1, and I'm left with the limit as x approaches 1 of just x plus 1. You can leave it in brackets if you'd like. And then it said once you have factored, simplified, rationalized the expression, then you can go back and sub in that value again as x approaches 1. So then I can go ahead and sub in the 1. So 1 plus 1 is equal to 2. 2 is a numerical value, so it has an overall limit of 2. So if I'm approaching from the left and the right, if I'm approaching from the left-hand side or from the right-hand side, there is no open hole at the value of 1. I would have a y value of 2, right? I'm approaching, nearing 2. So the limit exists and it's continuous at that value of x approaching 1. Okay, what about the next one that has a radical here? The limit as x is approaching 0 of the square root of 4 plus x, subtract 2 over x. So first is again just to sub in my 0. 4 plus nothing, subtract 2 over, well, over 0 was already kind of an alert for me there, right? But what's the top going to be? 4 plus nothing is 4. The square root of 4 is 2. So 2 minus 2 over 0 is 0 over 0. So 0 minus 0 is again, 0 over 0, sorry, is again an indeterminate. I can fit that here. I need more room down below. Indeterminate, which means I haven't really figured out anything yet. It could be continuous, but I have to continue on and either factor, rationalize, simplify. So it doesn't look like this is factorable at all, right? So there's no factoring, but I can rationalize, which is something new we're going to learn. So I can rationalize here. So what do I do? So to rationalize, I would write out, first of all, therefore the limit as x approaches 0 of my answer of 4 plus x minus 2. And what I want to do here is make it look like a factoring difference of squares question. So for my numerator, I have the square root of 4 plus x minus 2. And so if this was a difference of squares, my answer would be the same term again in the beginning of the bracket, the square root of 4 plus x, the same ending term, but one would be a minus sign and one would be a plus sign, right? And then divide by x, and whatever I did to the top, I have to multiply the bottom by as well, x multiplied by this same right-hand side here, so that really I'm just multiplying it by 1, which isn't changing anything. So multiply by the square root of 4 plus x and make sure that it's the positive 2. Okay, so how does that help me from here? So I have 2 binomials multiplied by each other. So what I can do is FOIL these, right? So first, outside, inside, last. So let's go ahead and write that out. Equals the limit as x approaches 0 of square root of 4 plus x multiplied by the square root of 4 plus x, or the square root of 4 plus x squared, gets rid of the squared and the square root, and I'm just left with 4 plus x after all that. And then I have the square root of 4 plus x multiplied by 2, so put the plus 2 in front, multiplied by 4 plus x, negative 2 multiplied by square root of 4 plus x, negative 2 in front, multiplied by 4 plus x, negative 2 times positive 2 would be minus 4. And then I copy out the bottom. The radical in the original question, right? For the original question, the radical was in the numerator, so I'm not touching the denominator. If the radical was in the denominator, then I would. But because the radical that I'm dealing with, the change that I'm making was originally in the numerator, I'm changing the numerator and not touching the denominator. So the denominator stays the same. And then let's see what I can do with this. Okay. So I have a 4 here and a minus 4. Those cancel out. I have a positive 2 square root 4 plus x minus 2 square root 4 plus x. So actually I'm just left with, change my color back to red. I'm just left with the limit as x approaches 0 of just an x on top divided by x multiplied by square root of 4 plus x plus 2. And then I can continue to cancel, right, the x's. And then I'm left with one over square root of 4 plus x plus 2. And now I cannot continue on any further. So now I can sub in my, my limit as x is approaching 0. I can sub that in. So I'm just over here on the right-hand side is equal to 1 over the square root of 4 plus 0 plus 2, which equals 1 divided by square root of 4, 2 plus 2, which is equal to 1/4. So my answer is 1/4. So I'm imagining that I have a graph that's approaching an open hole there. So here is, again, if you wanted to look at this in any further detail, it's page 35 of the textbook. Limit properties. So the limit of a constant is equal to the constant. That would be like example 1b, way up above here. The limit of a constant number is just equal to that constant number is just equal to 7. All the x values would be equal to that number because it's a horizontal line. So just to show that one there would be an example of 1b. Okay, the limit as I approach a of x would be equal to a. The limit of x as x approaches a is equal to a, meaning that the limit exists basically. So I have y equals x, right? And the limit exists. What about 3? The limit as x approaches a of f of x plus g of x is the same thing as taking the limit of f of x as x approaches a, and then taking separately the limit of g of x as x approaches a, and then adding them together. So the limit of a sum is the sum of the limits. Same thing, and that would be like example 1c. But there's really no need to do this. This is just faster. I can do it this way, which would be the same for subtracting. Subtracting the two terms and then getting the limit of them would be the same as separately finding the limit, and then subtracting the answers. Okay, the limit as x approaches a of f of x multiplied by c is equal to taking the limit of f of x as x approaches a, and then afterwards multiplying by c. So whether you multiply first or multiply later, it doesn't matter. So if this c here, and all we're saying is out in front, which is what this is saying, the limit of a constant times a function is the same thing as is the constant times the limit of the function. Multiplying, it doesn't matter the order in which you do it, right? And just moving up here. So number 6. The limit of f of x multiplied by g of x is, again, getting the limit of f of x separately, then the limit of g of x separately, and then multiplying them. The limit of f of x divided by g of x and getting the limit as x approaches a is the same thing as getting the limit of f of x as x approaches a, and getting the limit of g of x as x approaches a, and then dividing them afterwards, right? Provided that g of x obviously can't equal 0. If I have an exponent, taking the limit of the function to the exponent would be the same thing as getting the limit of the function first and then taking it to the power of the exponent. And same with square rooting. I can square root the function and get the limit as x approaches a, or I can have the function as x as the limit as x approaches a, and then take the square root of that, and then get after I've already approached the limit. If the root of the right side exists, the limit of a root is the root of the limit, provided that the root exists. Obviously, you can't have a negative sign underneath the square root sign, as long as the root exists. So finally, the piecewise ones that we were talking about before would be, let's write that down here, would be jump discontinuity. This would be an example of jump, which I believe was the middle one, discontinuity. So for example, we have a function, and the function is linear here, negative x minus 6, if x is less than or equal to negative 4. So it's linear, approaching in from the left, all the way up to negative 4 and including negative 4. Once I get to negative 4, the function changes to a different expression of x plus 3. So y equals mx, right, plus b is still linear. It's got a degree of 1. Between negative 4, not including, but between near negative 4 and up to and including negative 2. And then at the value of x equals negative 2, x is greater than negative 2, it's now parabolic, and it has the equation y equals 1/4 x squared, right? So these two are linear, this is parabolic. That doesn't really matter, it's just showing that there's different sections of this graph are representing different expressions. So when I'm taking the limit of something, I need to be careful with where I am. I need to decide which expression, which equation I'm looking at. Is it the linear portion? Is it the parabolic portion? So let's just start with looking at an example. So if I'm looking at the limit of f of x, so it could be either one of these, but x is approaching negative 4 from the left-hand side. So now the side actually makes a big difference here. If I'm approaching from the left-hand side, negative 4. So approaching from the left-hand side up to and including negative 4, I'm using this equation, negative x plus 6. So here I would write down, I'm equaling the limit as x approaches 4 from the left of the function negative x minus 6. And then now that I know which part of the expression I'm using, I sub in negative 4 in for x. So again, once I'm subbing in, I don't need to write limit or as x approaches anymore. So I can just go ahead and write negative. Now what's my value of x? Negative 4. So be careful with that double negative. Subtract 6. So that's positive 4. 4 take away 6. So I have a value of negative 2. So it exists. Right? It's continuous at that point of approaching negative 4. What if I approach negative 4 though, but from the right-hand side? Do you see the difference here? So if I'm approaching negative 4, but from the right-hand side, I'm not, this is a limit, right? I'm not at exactly negative 4. I'm just approaching, I'm nearing negative 4 from the right-hand side would be this section here, which would mean I'm using this part of the function, x plus 3. So then I would write out the limit as x is approaching 4 from the right side, I'm using in brackets the expression x plus 3. And then now that I know which one I'm using, I can sub in negative 4. I don't have to write the limit anymore. And I get a value of negative 1. So now for C, it's asking me, well, what's the overall limit? What's the limit as x is approaching negative 4? Not from the left, not from the right, but remember, for the limit to exist, these values need to be the same. Approaching from the left and the right, I need to be narrowing in on the same y value, and I'm not here. So in this case, the limit does not exist. The overall limit does not exist, which means that this graph has a jump discontinuity, just like here, jump discontinuity. Let's look at and continue on here with D, E, and F. So we're looking at the limit as x is approaching negative 2, right, from the left side, as x is approaching negative 2 from the right, and what is the overall limit as x is approaching negative 2. So just to leave I'll just talk about it, so I need to move this up so I can write it down. So at negative 2 coming from the left, negative 2 coming from the left, I would be in this range here. So I'd be looking at the equation of x plus 3. -2, coming from the right-hand side. Coming from the right-hand side, right? And I know that this isn't equal to -2, but when I'm looking at the limit, I'm only approaching, right? I'm not exactly at -2. So if I'm approaching from the right-hand side, I would be here in this range. So I'd be looking at the equation f of x equals 1/4 x squared. So I have to write 1/4 x squared for this section and x plus 3 for this section. And let's see what our limit is. Do they equal the same value? So here, the limit as x is approaching -2 from the left-hand side, we are using the equation of x plus 3. So then when I plug in the value of -2 in for x, -2 plus 3, I get a value of +1. When I'm looking here at the limit, as x is approaching -2 from the right-hand side, I am using the expression of 1/4 x squared. I'm just writing out like that, same thing. So then to sub in my x value of -2 and square that, right? BEDMAS, -2 squared is 4. 4 multiplied by 1/4 would be 1. So I do get the same values. So then the limit as x is approaching -2, the overall limit from either side they're the same number. So it does equal 1 and the limit exists here. So it's a continuous curve at this point. At this point of approaching -2, it's a continuous curve. Okay, let's look at the limit as x is approaching -6 from the left side and from the right side. So just to go back up first and take a look at where does -6 fall in my 3 different equations, right? -6 is less than -4, so I'm using -x minus 6 for both. So the limit as x approaches -6 from the left-hand side is using the equation -x minus 6. And then I go ahead and plug in my x value, negative, but my x value is -6. So again, be careful with that double negative. So I have +6, take away 6, and that would be 0. So on the right-hand side, my limit as x is approaching 6 from the right-hand side is using the same equation, -x minus 6. So -6 is, I should have written a negative sign there, sorry. -6 from the right. -6 minus 6 is +6 minus 6, and I get 0 as well. So the limit as x is approaching 6 overall exists and is 0. What about here? All I've done is, you see how here I have approaching from the left, approaching from the right, and then overall limit. Here I don't have approaching from the left or the right. I'm going straight away to the overall limit. So let's look at why is that? I'm looking at the limit as x approaches 3. So let's take a look up above at what's happening at x approaching 3. Well, 3 is greater than -2. So I'm using the 1/4 x squared expression, right? So whether I was approaching 3 from the right side or from the left side, I'd be using the same equation. So if I'm using the same equation and plugging in the same number, I'm going to get the same answer, meaning that the limit would exist, right? So let's write out what that answer would be. So the limit as x approaches 3 from both sides would be using the expression 1/4 x squared. And then when I'm ready to plug in my answer, I don't have to write the limit or as x approaches anymore. So 3 squared is 9. 9 multiplied by 1/4 would be the same thing as 9 divided by 4. And again, I can leave that as a fraction. I don't have to change that into a number. I know that it's not a number over 0 or a 0 over 0, so I know that the limit exists. And I know that it's a continuous function at that point.